A car moving along the x-axis starts from the position, which is the initial position to be 2 meters, and at this the time is 0, and stops at the final position, which is -3 meters, where we have that the time at this position is 2 seconds. So there are two parts to this problem, where A, we're told to find the displacement, the average velocity, and the average speed during the time interval. Coming to B, we have that if the car goes backwards, so meaning going back to the initial position, it takes 3 seconds to reach the starting point, then repeat part A. So for the first one, to find the displacement, which is the overall change in position, we know that this simply gives us the final position that we have to subtract with the initial position that we have. So it will be x final, which is the final position, minus x initial. So the final position according to our problem is given as -3 meters. It's given as -3 meters. Then minus the initial is 2. So it will be -3 meters minus 2 meters. And this will simply give us a -5 meters. So it is fine as obtaining a negative for displacement, because this negative would tell us a direction. So it's either get a positive for displacement, and also getting a negative is not a problem. Come to the second one, where we find the average velocity. So in this case, our average velocity will be nothing but the maximum displacement over the change in time. So what you get is, for the displacement is a -5 we had, for the overall change in position over the time, where you say the final minus the initial. So for the final, we have a -3, then minus 2. Then what you now do is divide with the final time we have is a 2, then subtract with the initial is 0 according to our problem. So -3m minus 2m is equals to -5. -5m, then divided by 2 seconds. That is for time. So 2 into -5 gives us -2.5 meters per second. So this is our average speed, of which negative simply represents the direction. Okay, we now come to the next part, where we find the average speed. Now average speed and velocity are the same, just that in this case we're only interested in the size but not the directions. So our average speed will be calculated as the total distance over the total time taken. So we're going to say total distance divided by the total time taken. Then you divide with the total time taken, like I had said. So what you have is total distance is just the size we get for the displacement, but not including the negative, because negative is for direction and distance just looks as the size. So we're going to get a 5. Same one we had obtained for displacement, but here positive this time around. Then you divide with 2. So 2 into 5 will simply give us 2.5 meters per second. Okay, so that is what you get for the average speed. So from there, you now move to the next one, which is as finding B. So B was simply repeating what we have in A. Now given that this same particle goes back, the car we have goes back to its initial position. So we have that the displacement will be equals to 0, because we've gone back to our initial position, because it went back to the starting position. That's why we obtain displacement in this case to be a 0. So that's what we get. Then moving to the next one, we are finding the average velocity, of which average velocity is equals to the displacement over the time taken. So for the average velocity, what you have is the 0 that we have for the displacement, 0 you have for the displacement, then you divide with the time. Now the time in this case is 3 seconds according to our question. So we're going to say 0 divided by 3 seconds. Okay. So this will give me 0 meters per second. Then you come to the next part. Next part, you're finding the speed. Why you're saying that total distance is 5.5 over the total time. Now total time in this case is 3. Okay, so even in the first part we made an error. It's not supposed to be 2 but rather 3. So we change this first one to be 3. Then 5 over 3 is 1.67. Then it is meters per second.